Nickel-Cadmium Batteries by Bailey Jones, Benjamin Levine, and Francis White. Nickel-cadmium batteries, better known as NiCad batteries, are obviously composed of nickel and cadmium. The nickel forms the cathode, which means that it's being reduced, while the cadmium forms the anode, which means that it's being oxidized. Here are the half reactions for the reduction and oxidation in the battery. The reduction half reaction for nickel goes 2 nickel oxide hydroxide plus 2 water plus 2 electrons yields 2 nickel hydroxide plus 2 OH ions. The oxidation half reaction for cadmium goes cadmium plus 2 nickel oxide hydroxide plus 2 water yields cadmium hydroxide plus 2 nickel hydroxide. Balancing and adding the two half reactions gives the end equation cadmium plus 2 nickel oxide hydroxide plus 2 water yields cadmium hydroxide plus 2 nickel hydroxide. This is the process through which the battery generates electricity. Here you can see the diagram of a typical NiCad battery. There are separated layers of cathode and anode, and these are each connected to a metal plate on the top and on the bottom of the battery. These metal plates are attached to the circuit. When the circuit's connected, ions can flow from one end of the battery to the other. This means that electrons will be flowing out of the cadmium layers of electrode and into the nickel layers of electrode, because cadmium is the anode, which means that it's losing electrons, while nickel is the cathode, which means that it's gaining electrons. NiCad batteries are unique in that they provide about 1.2 volts throughout their entire discharge cycle, and this is different from other batteries because it doesn't go down as the battery depletes. The most notable benefits of NiCad batteries are this constant voltage and a very high amperage that they provide, which means that a lot of electricity is being moved through the wire. Since lots of current can run through them very quickly, this also means that NiCad batteries can be recharged much faster than other batteries. NiCad batteries are also used in all temperatures, although they are best in low temperatures. And finally, they're smaller and lighter than lead-acid batteries that can provide a similar voltage and current. Despite all of this, there are some major issues. Nickel-cadmium batteries are actually very expensive. They're also less efficient than modern nickel-zinc batteries, which means that they're heavier while providing the same power. NiCad batteries also discharge while in storage, meaning that if you don't use them for a while, you need to recharge them before using them. And finally, one of the most major problems with them is that cadmium is toxic, which means that it's very difficult to dispose of NiCad batteries without harming the environment or people who live around the disposal area. The most common use for NiCad batteries is in cordless power tools. This is because they're very easy to recharge, and they work in a range of temperatures, which is perfect for tools that you can take out and use anywhere. Since the voltage of the battery doesn't decay over time, this is also perfect for power tools, because obviously you wouldn't want your tool to stop working as you got low on charge. NiCad batteries have a fairly mundane history. They were invented by Swedish engineer Ernst Jüngner, in 1899, and they became very popular in the 1990s, but more recently have dropped out of fashion as lead-acid batteries have become much more popular. A few interesting tidbits about NiCad batteries are that their capacity is less than nickel-zinc rechargeable batteries, which is mainly why they stopped being used so often. Also, their electrolytes are most commonly KOH, LiOH, and NaOH. Despite being mostly out of fashion, they're still one of the most popular batteries used today. But the most interesting thing we found about NiCad batteries is the memory effect. And essentially what this is if you repeatedly discharge the battery to around 25%, or any amount that's greater than 0, you'll find that it eventually starts setting that percentage as its new baseline. So below that percent, say 25%, it'll stop providing its normal voltage. And this is really interesting, and we looked online and we couldn't really figure out a good explanation for that. It seems like there aren't really many good explanations for that, and it's different than a lot of other phenomenon that can cause batteries to deplete early, for example, deep discharge. So that's an interesting little mystery about NiCad batteries. Here are our sources.